Hey guys, welcome back to my channel. So today we'll start with the next part, that is performance engineering. If you haven't seen the first video, you can go back and see where I explained the performance testing basics. So without wasting much time, let's start with this. Performance engineering is basically a discipline consisting of systematic process comprising of investigation, testing, measurement and analysis used to predict, investigate and quantify the system. Performance testing is where we test our software, and performance engineering is where we assess our system and we make it better by analyzing the issues and defects, and by predicting or by suggesting them the new solutions which can enhance your application. So a thorough performance engineering exercise entails not only running the performance test but closely analyzing the results also. Once we are done with the test, till that part, that is performance testing. So after the results are there, we do analyze those results and then we suggest some changes in your system. That suggestions, those where the issue is, these all things come into performance engineering. So the focus of performance engineering is to isolate, identify performance issues early in the cycle. Okay, so the question arises is, what is the difference between performance testing and engineering? So the basic difference is, performance testing is where we evaluate our application, performance engineering is where we eliminate our issues. Performance testing is basically where we assess the system, in engineering we address those issues. So in testing we find problematic areas, but in engineering we fix those problematic areas. Performance testing methodology. So in this, what we do, we actually predict, and we predict the software behavior. We actually plan all those scenarios to make sure that we are making our application more efficient. Okay, so this is a performance testing methodology, a diagram actually which explains you how this whole process goes. So if you see, there is requirement analysis, then planning and design, execution and recommendations. This part comes into engineering. This whole part comes into performance testing. So you can see, we kick off the project, then we gather the architecture and environment assessment, then we do NFR analysis. So NFR means non-functional requirement analysis. Then after that we create business requirement and actions, workload modeling we do, performance testing, strategizing and tool identification we do. Once this part is done, we go to architecture level where we study the architecture of system. Then we create those test scenarios based on our studies and our findings. Then we design test stops. Basically test stops are small tests which are a part of a performance testing. Then we validate our dry run. Dry run is basically once your script is ready, you validate those scripts with a minimum load, let's say with only one or two users, so that you are making sure that your application is behaving well. So because there is no point of running a whole load test when your application is not able to handle a 10 or 15 user load. So that's why we do a dry run, to make sure that everything is fine and our application is stable, so that we can put more load on that. Once this part is done, we go to execution part where we put a certain load, whatever is defined, and then we execute those execution scripts. Then after that we collect the results and we analyze those results. So till this part our performance testing is done. Then we recommend some changes, that what we can do to make your application better. What, either it is a database change, either it is application change, either it is a web server change, whatever changes you see in the system, whatever changes you dig out by your analysis, you can recommend those changes to your developers or testers or your business team, so that they can implement that and tune your system. So that includes iteration tuning, recommendation report you say, post deployment reviews you do, and once this is done, we deploy our application to a production server. These are different features of performance testing project. So in this, we do the same thing what we do in manual testing, but the approach is different. In this, we just first we do the requirement analysis, we test the requirement, we plan and we strategize those. Then our test strategy and plan is created. Then test design and development is created. After that, we create test scripts. Then we create test designs. then test executions and result. Then after this, we actually execute those, and if everything goes fine, we deploy it to the server, and if not, then we tune it. That is called iteration tuning. Let's say once we are done with the test, we'll see either we that test is satisfactory, that test is basically under our SLA or not. If it is not, then we'll suggest some changes. Once those changes are done, then we'll again do a performance testing. So that is called tuning iterations. We'll in every iteration we'll tune our system and see now how my application is responding. Either is good, either it is bad. So based on our changes, once we are done with the iteration tuning, we say that okay, this application now can handle your suggested load, whatever you have defined, and we can say this load will go till, let's say, 3 months or 4 months, whatever cycle you have decided. So these are basically various phases, the same what I explained earlier. In requirement analysis, you actually get the requirements. In planning and design, you do the workload modeling, you design the scripts, you design the stubs, then execution is done. Okay, you gather all the desired matrices, and then you recommend those things. You recommend some changes to your database, to your application, whatever you see in the system, you recommend those changes so that it can make your application better. So the question arises, what is critical scenario? If you remember, I have told you that critical scenario is those scenarios basically which are impacting your business in any way. So whatever scenarios are impacting your business, whatever scenarios are important for your application, those all scenarios come into critical scenario. So just a refresher, virtual user, basically those users which are created by machine. So response time and think time. Response time is basically a request going and a response coming. So difference between these two is your response time. Think time is basically the time taken by a user to decide where to go. So that is basically a think time. Concurrency is how many users are on your system at a particular time. Maximum TPS, this is something which we'll learn in our Jmeter. Once we start our Jmeter, I'll tell you how you can achieve a maximum TPS, that is transaction per second. And characteristics of critical scenario, you already know, I have just explained it. That's those scenarios which are impacting your business come into critical scenarios. So if you have any questions, you can post in the comment. I'll try to answer them as much as I can. And also please subscribe my channel if you like the video. I'll be posting one video every week so that we can have a time to learn and to explore. Thank you. Thanks for watching, and stay tuned for the next video. In the next video, we'll talk about Jmeter, how Jmeter works, and how can we create a simple test plan. Thanks for watching. Bye bye.